Hello. So today we will discuss about the Archimedean property of R. So first we see what is the statement of Archimedean property of R. I am writing this here, the statement of Archimedean property. The Archimedean property says that if we take any two numbers from real number, so I take x comma y from R, and x comma y are positive real number obviously, then there exists a natural number small n that belongs to script n, that is the set of natural number such that ny is greater than x. That is the statement of Archimedean property. It is a very important property in real analysis, also in point set topology. So basically we have to understand what the statement is saying. So let us take any two number. Let me take 3 comma 4. Obviously these two numbers belong to real number, okay, and I take 3 as y. See here, see the statement, we take two number x comma y belongs to R, so I take here two number 3 and 4 as y equal to 3 and x equal to 4. Then by the statement of this theorem we can conclude that, see here, there exists n belongs to natural number such that ny greater than x. So here y is equal to 3, then we can write 3 is greater than 4. It is not possible in general, but what Archimedean property says that we can find a natural number n such that ny greater than x. Is it possible? Yes, because if we take n equal to 2, then by this ny greater than x we can say that 3 into 2 that greater than 4. It is true, because 3 into 2 is 6, that obviously greater than 4. So if we take any number greater equal to 2, if we take any number that is greater or equal to 2, then the above condition is fulfilled for these two numbers 3 comma 4. Basically Archimedean property says that if we take any number from real line, obviously positive number, then we can find a natural number. If we multiply the natural number with this number, then this is greater than the another number. So we have to prove this statement. Just a second. So first let, if possible, let there doesn't exist any natural number that satisfies this condition. Okay, basically we prove this theorem by contradiction method. So firstly we assume that if possible let there doesn't exist any n that belongs to natural number such that satisfy the above condition. So we can take the negation of ny greater than x. The negation is then for all k belongs to natural number ky is less than x. I just take the negation of this, sorry, less or equal to. I just take the negation ny greater than x. We assume that this condition, there doesn't exist any n. We can't find any n that satisfy the following condition, the above condition. So we take the negation of this statement, that is, for all k belongs to natural number ky is less or equal to x. We know that here where the sign is greater than, then the negation obviously less or equal to, so ky less or equal to x. Okay, let us consider a set. So consider the set is ky such that k belongs to natural number. Okay, clearly this set is bounded above because this. So we see here for all natural number k belongs to n, ky is less or equal to x. Then we can say that a set is bounded above by x, obviously. So this is bounded above. Bounded above by x. We also say that S is non-empty. Why? Because as k belongs to natural number, then we can take k equal to 1, 2, 3, 4 and so on. So if we take k equal to 1, then y belongs to this set. Y belongs to this set S. So S is non-empty. We can say that. Then what we get from above, that S is bounded above plus non-empty. Then by supremum property or least upper bound property, supremum of S exists. So let supremum of S that equal to B. Since supremum of S exists, then we let that supremum of S is none other than a real number B. B. Since supremum of S exists by least upper bound property or supremum property of R, then we take that supremum of S is B. Okay. Since B is the least upper bound of the set S, then we can say that ky is less or equal to B for all k belongs to natural number. Why? Because we know that we define A set as ky such that k belongs to natural number. Okay, and we see that the least upper bound of S is B, then all the members in S are less or equal to B, obviously, because B is the supremum of S. So now we know that y is greater than y. It is given in the statement of Archimedean property of R. Y is greater than 0. Then we can write b minus y is less than b, obviously. So what you can conclude from here, that imply b minus y is not an upper bound of S. Okay, because B is the least upper bound. B is the least upper bound of this set. Then any number that is less than B is not an upper bound of S. Then there exists a natural number P such that b minus y less than py less or equal to b. It is a theorem. It's a theorem. So we see here that b minus y is not an upper bound of the set S, and we already know that supremum of S that equal to b. So b minus y is not an upper bound and b is supremum of S. So we can find a natural number p that is lie between b minus y and b. So from here we conclude that b minus y is less than py. From here we can take only this inequality. Okay, then we can write p plus 1 into y that greater than b. We assume that p belongs to natural number, then obviously p plus 1 is also belongs to a natural number, and y is any positive quantity from R. Then this full quantity is going to S, is a member of S, because member of S are looks like ky type, where k belongs to natural number. So this quantity, so this quantity p plus 1, it is a natural number, belongs to natural number because p belongs to n. Then p plus 1 obviously belongs to n. Then the whole number, that is p plus 1 into y, that belongs to the set S. Okay, because S set is look like this, k into y, where k belongs to natural number. Here we see y is here and this belongs to natural number. So we can say that p plus 1 into y that belongs to S. Okay, and also we see that p plus 1 into y that greater than b, and we know that b is upper bound of the set, least upper bound of the set S. Okay, so my contradiction is arise as so we know that supremum of S that equal to b. We assume it supremum of S that equal to b. Okay, so since supremum of S that equal to b, then any number that greater than b cannot belongs to S, because S is supremum of S. So this is a contradiction. I think you can understand that what I am saying. I am saying that we take supremum of x is that equal to b. We let that since the S set is bounded above plus non-empty, then by least upper bound property, or we can say that supremum property of R, we can say supremum of S is exist. Since supremum of S is exist, then we can take supremum of S that equal to b. Okay, and we see here that p plus 1 into y, this belongs to S, and this number is greater than b. So this number is belongs to S, p plus 1 into y that belongs to S. But the condition is here that the problem is that we know supremum of S equal to b, and we see here that p plus 1 into y that greater than b, and also this number belongs to S. It is not possible because we know that supremum of S equal to b. Any number that greater than b, it cannot contain in the set S. Okay, so but we can see that these things happen, but it is not possible, which is contradiction that supremum of S that equal to b. That is contradict our fact that supremum of S that equal to b. Hence Hence our assumption, just a second. Hence our assumption is wrong. What we assume? We assume that there doesn't exist any n belongs to natural number such that n y greater than x, where x greater than 0, where x greater than 0, y greater than 0. But we prove that there exists. Obviously we can find a natural number such that nx greater than y. That is our Archimedean property. So basically, what do you want to say? I want to say that if I draw the real line, okay, this is our real line, and let me take, this is 0, let this is our 1, and this is 2, and so on. So this is 2, and this is -1, and this is so on. So we don't take the negative part, because in the statement here define that x is greater than 0, y is greater than 0. If this condition hold, then we proceed the following. So take here. So what is the property say? Ny greater than x, okay, where n is any natural number, means 1 2 3 4 and so on. So if we take any number, let me take 1, I take 1, and another one take 2. So I take two number, 1, 2. Obviously these two number belongs to are real number. So can we find any natural number such that, so can we find any natural number such that 1 is greater than 2? Yes, obviously I can find. So let me take the natural number 3. So 3 into 1 is greater than 2. So you can feel it. I take the natural number for only for better understanding, and you can take any real number, any positive real number, obviously. So you can feel it. So you can take this number, okay, and this number, obviously. From the picture you see that this number is less than this number, okay, because in the real line you can see that this is less than this. But can you find any natural number? Can you find any natural number belongs to n such that this greater than this? Yes, obviously I can find any natural number. You can feel the statement. You can find any natural number such that ny is greater than x. So this is basically Archimedean property.